Is superintelligence using language models a dead end? Executive summary. Language models have transformed AI, but may not lead directly to superintelligence. They excel at generating and analyzing text, but lack grounding, goals, and real understanding. Their dependence on data and lack of autonomy limit them. While scaling can enhance performance, it may not produce consciousness or self-direction. However, when combined with perception and reasoning systems, language models could still play a key role in the development of future intelligent machines. Article: AI has changed how people think about machines. Language models are one of the most advanced forms of AI today. They can write essays, code programs, and chat like humans. Many experts believe that these systems are steps towards superintelligence. Others think they are a dead end. The truth depends on how we define intelligence and what goals humans have for machines. A language model learns by studying large amounts of text. It finds patterns in words and phrases. It predicts what comes next in a sentence. This process allows it to generate coherent and fluent language, yet it does not truly understand what it says. Its knowledge comes from patterns, not meaning. That difference raises questions about whether language models can ever become truly intelligent. Human intelligence is more than pattern recognition. It involves reasoning, emotion, creativity, and purpose. A human can form goals, adapt to new contexts, and imagine possibilities. Language models cannot yet do these things. They depend on training data and human prompts. Without input, they cannot decide what to do next. This limitation suggests that current AI models may not reach superintelligence. Still, language models show impressive abilities. They can summarize books, explain complex ideas, and write original content. Their skill grows with the amount of data and computing power used to train them. Each new generation of models seems smarter than the last. This progress leads some to hope that scaling up might eventually produce superintelligence. Others argue that no amount of scaling can replace understanding. One argument against language models as a path to superintelligence is their lack of grounding. Humans learn through experience and interaction with the world. We connect words to physical objects, actions, and emotions. Language models only see text. They have no direct experience of reality. Without grounding, their words lack true meaning. This gap limits how deeply they can understand or reason about the world. For example, a child learns what fire means by seeing it, feeling its heat, and hearing adults talk about it. The child links the word to sensory and emotional experiences. A language model learns about fire only from sentences in its training data. It knows how to describe it, but does not feel what it is. This difference shows why models may always lack real understanding. Another problem is that language models cannot form genuine goals. They respond to prompts, but do not initiate actions. A superintelligent being would need self-direction. It would have to make choices and pursue objectives without constant human input. Current models have no built-in motivation or awareness. They are powerful tools, but not autonomous minds. Critics also note that large language models use enormous resources. Training them requires vast amounts of energy and data. The environmental cost is high. As models grow, these costs rise even more. This makes the idea of endless scaling less practical. The world might reach a point where more data and power add little value. If that happens, the language model approach could stall. Another concern is bias. Language models learn from human-generated text, which contains errors and prejudice. When models reflect these biases, they can produce unfair or harmful outputs. This weakness shows that their knowledge is only as good as their data. Fixing this problem is difficult because human language itself contains bias. A superintelligent system built on biased data might make dangerous decisions. Despite these flaws, language models still provide valuable insights. They show how much intelligence can arise from statistical learning. They help researchers explore the limits of computation and cognition. Some believe combining language models with other systems could overcome current barriers. For example, connecting them with robots or sensors might give them real-world grounding. Adding memory and reasoning modules could make them more autonomous. The key question is whether these combinations will produce true understanding or just better imitation. Some scientists argue that human-like consciousness requires something beyond computation. They think awareness comes from biological processes or complex feedback loops that machines cannot copy. Others believe that if behavior becomes indistinguishable from human thought, then functional intelligence exists, even without consciousness. There is also the issue of safety. Even without superintelligence, large models can cause harm if misused. They can generate misinformation or manipulate people. If a model ever approached superintelligence, controlling it might be impossible. Researchers are already studying ways to align AI systems with human values. They hope to build safeguards before models become too powerful. Supporters of the language model approach say progress should continue. They argue that dismissing language models as a dead end is premature. Every scientific field faces limits until new methods appear. Early computers seemed simple compared to the human brain, yet they transformed the world. Language models may seem shallow now, but could evolve into something far more advanced. Opponents reply that chasing bigger models distracts from real understanding. They call for a shift toward hybrid systems that mix symbolic reasoning, perception, and experience. They believe true intelligence must involve interaction with the world, not just text. According to this view, language models are tools, not paths to superintelligence. The debate reflects a deeper question about what intelligence means. Is it the ability to process information, or the capacity to understand meaning and purpose? If intelligence requires consciousness and moral awareness, then language models may never reach it. If intelligence means solving problems efficiently, then perhaps they already qualify. The answer depends on values as much as science. In the near future, language models will likely keep improving. They will assist in research, education, and creativity. They might even simulate human reasoning better than people expect. Whether this leads to superintelligence remains uncertain. It may turn out that language models form one part of a larger system that achieves it, or they may stay as powerful but limited tools. Calling language models a dead end may be too strong. They represent one branch of the AI tree. That branch might merge with others, such as robotics or neuroscience, to create something greater. Superintelligence might not come from one model type, but from integration. The current path may seem limited, but it could still open the way to future breakthroughs. In the end, the question is not whether language models alone can achieve superintelligence. It is whether they can play a role in building it. Their strengths in language, pattern recognition, and communication make them essential tools, but real understanding and autonomy might require more. The future of AI will depend on how humans combine these tools to create new forms of intelligence. Is superintelligence